All right, welcome back. So we're having a go at the next set of questions here. All right, so we've got a new question here, e to the minus x. Now, this is trivial if you have learned how to do shortcuts on your differentiation and your integration. You'll probably look at this and scuffle and score a little bit, but the reality is the thing about this is that it's about knowing what you're doing. Okay, so this is the thing for me. So I'm actually going to do a whole U substitution on this. So just bear with me while I do that. So we're going to, because x is being e, but it's also being minus, so it's a 2 function. Yeah, the derivative isn't there in the sense, but I'm going to do it anyway. So let u equal minus x stay in the column, as it were, and du dx is equal to -1. Now, clearly that's not there anywhere. So by the time we multiply through and do a bit of work, we'll get minus du is equal to dx. Are you there? Yep. So we're going to go and replace it. So our replacement gives us du, but now there's a minus out the front. Now, if I just put the minus out the front, I can show you something that I want to do here. I won't do the trivial yet because I want to go away and do the function notation. So the function notation will be, let's have a look when we had a 2. So we get a minus 2. So where before we had a 2, we now have a minus 2. Where before we now had a 1. So we're going to put 1 in as a function notation. And so it's minus 1. And so we'll get minus 1. So where before we had a 1, minus 1. Minus 1 to minus 2 is kind of the wrong way. We'll do the trivial now, and u was minus x, so this is simply e to the u. And we don't need to do this. A lot of people will say, oh, just put the minus out the front, and it's minus e to the minus u. So if you're integrating e to the minus x dx, just recognise that it's minus e to the minus x. Well, as a shortcut, fine. But if it's 2x, what do you do then? If it's sine x, what do you do then? So we just need to be a little pragmatic and be prepared to do a bit of work, even on the most obvious of cases. For some people, obviousness is a means to kind of, we're in tertiary education. Why are you dealing with the obvious? Well, I'm sorry, that's who I am. I deal with the obvious. Okay? Now, another thing here is I don't like this integral. I don't like the fact that it's there. I don't like that it's minus. So you know what I'm going to do? I'm going to borrow the idea that we had earlier, where if we multiply a minus 1, we can swap the unit. Oh, well, let's do it. Let's do it. Let's times this whole thing by minus 1. So we're going to get minus 1 times minus 1 to minus 2, e to the u du. That has the effect of making a plus. So I don't need to be a minus anymore. And it has the effect of doing this. Minus 2 to minus 1, e to the u du. Let's see what happens to the final result, because the maths shouldn't matter. Let's go ahead and do the integration. This is the one we love, isn't it? Because e to the u is just e to the u. Wonderful. Between minus 2 and minus 1 by the fundamental theorem of calculus. Okay. So far, so good. I like the look of that. Then we better put in our scaffolding. And we're going to put a minus 1 here, wherever u is. On this case here, we're going to put a minus 2, wherever u is. And what are we left with? E to the u. E to the u. So we're going to put a minus 1 in there, and a minus 2, and that will give us e to the minus 1 minus e to the minus 2, which is what? 1 over e minus 1 over e squared units squared. Wow. So it's given it to us in an exact value. Okay. Now, what's lost? The shortcut. Okay, what's lost? Who cares? Now, if I didn't do the reversing here, okay, if I just didn't bother with the reversing, what would have happened? Well, if I'd had this as minus 2 minus 1 e to the u, go ahead and do your integration. We would get minus e to the u from minus 2 to minus 1 by ftc. Doesn't matter. Doesn't change anything. Okay. That now is a bit more aligned with the shortcuts. Okay, so for those that have learned shortcuts, that makes a bit more sense. We're going to leave the minus outside and put our scaffolding in. This time we're going to drop minus 2 into u here and minus 1 into u here, and it's e to the u. E to the u. We're going to put minus 2 in here. You can see what's going to happen. Minus 1 in here. So we've got a minus outside. So this one was minus 2. E to the minus 2 minus e to the minus 1. How's that work? Minus outside of 1 over e squared minus 1 over e. Now, do the expansion. Do. We get minus times a minus is a plus, and minus times a plus is a minus. So this ends up being 1 over e minus 1 over e squared. Yeah, oh, it's the same. Yay, look at that. So the quest to make the shortcut a prevalence, I believe, is flawed. So I'm asking you not to do it. Okay? Forget about the flawed shortcut, because there's 2 dx's here. I'm just getting rid of one. Because as far as I'm concerned, it's not necessary. Okay? As far as I'm concerned, shortcuts are a waste of your time. And in terms of what you'll be encountering at tertiary mathematics at university, doing it this way will give you much more horsepower in dealing with your own errors and correcting them. All right, so let's have a look at this one, 1 over 2x. Now for the quotient, I want to test if the derivative is on the denominator. And so what I'm going to get asked, of course, is I'm going to get asked, well, wait a minute, why aren't you going to use a u substitution? If there's a thing that says, oh, wait a minute, if the derivative's on the top of the thing and the function's there, we can just go straight to the ln of f of x. Can we? Yeah, it's a substitution. That's a rule, right? We learned about that last time. We're going to have to do that one regardless of whether we do it now or later. So I'm going to try and squeeze this in so that you can see both things being done. So is the derivative there? Not quite, because the derivative of 2x is 2. So ideally we need a 2 on the top. So we're going to multiply this by 1, because anytime we multiply anything by 1, including a rather gnarly looking integral with a quotient in it, it does not change it. They are equivalents. The one that we want is 2 over 2. 1, 2, 1 over 2 to the x. So this is the maths that goes on at school. Okay? Now we're going to take this 2 and put it across here, because we're allowed to do that. We did that previously. So what we've got is 1/2 the integral of 2 over 2x minus 1 dx. Ooh, all of those 4 expressions are equivalent. Is the derivative of the denominator on the numerator? And the answer is, yes it is. So we can now write directly the solution, a substitution, this substitution over here. So because the derivative is on the top, we can simply write the ln of the denominator, which happens to be 2x minus 1. Now, the reason that I'm doing this to the extent that I'm doing it is because now that's by FTC, isn't it? By the fundamental theorem, is because you will encounter it many times in advanced maths at Maths 1. There'll be lots of equations where you get quotients. You may have to do a little bit of a manipulation and ultimately get to a Lin function. It happens a lot, so I'm just forewarning you. I'm going to do the U substitution over here. That's fine, but for this part here, it's just because this is what's going to come up. Okay. All right, I'm going to leave the half out the front. So I'm going to put a half and a bracket and put my scaffolding in. And here I'm going to bomb x with 1. And here I'm going to bomb it with 2. And so we get the ln of 2 minus 1. And the ln of 2 times 1 minus 1. And so that's 4 minus 1, which is 3. So we get the ln of 3. This is 2 minus 1. So we get the ln of 1. Now the ln of 1, what's the ln of 1? The ln function looks like this. The ln of 1 is 0. So this is 0. This one is actually zeroed out. So the ln of 1 is equal to 0. So I'm going to put a line through that one. And so we end up with a half of the ln times, but it's now the ln of 3 units squared. So the ln of 3 units squared, that's our final answer. Okay? So it's a little bit different in terms of its U substitutions because I'm asking you to remember this quotient rule. Now let's do the U substitution. I'll change the colour and we'll go back to like an orange or red. We'll do an orange just to differentiate it a little bit. So we'll do it this way, and then I can show you the similarity. So we're going to take 2x minus 1. So we're going to let U equal 2x minus 1. We're going to stay in the column, as it were. Du dx is just equal to 2, and multiplying and dividing as we need. We'll do some work, and we'll get 1/2 du is equal to the x, and we can clearly see that's up there. So the power of this is that we're able to make this substitution. Okay, that's where I would like students from school to be able to get to. The final thing, of course, is that we need to check our function notation. And u2 is equal to 2 minus 1. So we're going to put a 2 in there. u1 function notation is 2. We're going to put a 1 in there. So this is 4 minus 1, which is 3. So where before we had a 2, we now have a 3. And in this case here, this is 2 minus 1. So where before we had a 1, we still have a 1. And then we've got u, 1 over u. Now look at this. You can't make this u to the minus 1. You have to come here. And you have to say, is the derivative of the denominator on the numerator? So I pause when I do this in the workshop because I ask the question, what's the derivative of u? And I get a lot of blank looks. The derivative of x is 1. Easy. The derivative of u is also 1. So that's true. This is now in this form, so we can do a straight substitution. And so what we'll do is put in 1/2 the ln of u between 1 and 3 by FTC. This becomes a scaffolding step, 1/2. We're going to bomb that with 3. And we're going to bomb that one with 1. And what have we got? The ln of 3 and the ln, oh look, the ln of 1, there it is. Hey, the ln of 1 is 0. The ln of 1 is 0, so that's gone. So we're left with 1/2 the lim of 3 units squared. So there it is. It's the same one. But we still had to do this thing here. Here I just did it a bit more complicated, but it was a shorter route, I think. So we've got to get used to both, but I'm asking you to get used to looking for quotients and seeing if the derivative sits on top, and to what extent can we manipulate that, because there are some further manipulations that can be done that are quite involved and really do stir it up a little bit. All right, so I'm going to stop that one there. It's not quite 20 minutes, but I want to do some work on areas, and so we'll have a discussion about that in the next video. I'll see you then. See you soon.